Today on BRStv, we're going to welcome you to the next generation of controllers. Hey guys, my name is Ryan. Welcome to another week of the BRS160, where every week we do our best to help you guys, members of the reefing community, enjoy your tanks and find new ways to explore the hobby. We do that by following the setup and progression of this 160-gallon reef tank. This week we're still on the hunt for the best controller for the BRS160, and we have something brand new with the Vertex Cerebra. Well, it is new and only time will tell if the Cerebra becomes the #1 controller in the US. The promises the Cerebra makes absolutely changes the game of what we should expect from a controller in today's technology era. To be frank, there really hasn't been a tremendous amount of options for aquarium controllers in the US. Competition breeds innovation and forces everyone to meet the challenges posed by our competitors. The Cerebra promises to bring controllers out of the dark ages and into a world where devices are expected to not only improve our lives, but also do it intuitively. So I think their entrance into the market is going to be awesome regardless of what controller you end up buying, because they're all going to have to improve to meet the new bar. Beyond the Cerebra and controllers in general, I think there's two general expectations from any device or technology we purchase today. The first is it's a smart device that connects to the internet fluidly, and the other is I should be able to operate it almost immediately after opening the box and plugging it in. If I'm searching for a few hundred-page instruction manual the moment I turn it on, or scouring the internet for help, the amount of people willing to buy this product and ultimate customer satisfaction just got cut by 80 or 90%. Generally speaking, only advanced users and early adopters are willing to read massive instructions or search the internet for how to use a product. The rest of the world just wants to turn it on and have it work, but we should all take a moment and thank all of those early adopters, because it's their work that made the simple and easy product possible. More or less at this point, I think everyone expects any device to behave like our phones. Turn it on and the intuitive menu system allows us to do almost anything. Most of these really advanced devices don't even come with instructions anymore, and for good reason. If in today's environment your product testers requested instructions, you failed, and you should probably start over. For programmers, that's a major challenge because it's really hard to build something that's so intuitive that you don't need instructions. But simply put, that's a difference between programming for a retail product 10 years ago and doing it today. Expectations have changed and technology has advanced to the point that as long as that's your goal, it can be done. Now you might think, well, my aquarium is super advanced. There's no way anyone could build a device that behaves that way. That's just not true. We've just been trained to believe that's the case because of the products that have been presented to us. I can say with 100% confidence that we're going to see a product that achieves this for us. How can I say that? Well, I know the players that are involved, and I know many of them have that one single goal: no instructions. Why is that the goal? Because it's not just great for you, but it also opens the market from 10 or 20% of reefers to 100% and represents an enormous growth opportunity for them. More or less all the early adopters in technology or reefing gurus have proven the market and brought us into the new age. Making it easy and affordable is what opens it to the other 80 or 90%. On top of that, the amount of reefers making it past the 2-year mark is growing exponentially. Every single 5-year successful reefer will openly tell you that a huge part of their success is early recognition that equipment or elements of the life support system will fail at some point, and early detection of when the inevitable happens is a big difference between a 1 to 3 year successful tank and a 5 to 10. This acceptance is going to be a huge driver of controller demand in the future, because more and more reefers are going to demand some type of technology like this, but need it in a form they're capable of using. Enter the Cerebra into the conversation. Vertex recently released a video that indicates they're just weeks away from being released into the world. Vertex hasn't shared a lot of details in the release, but I do have a beta version here, and I've been allowed to play with it, and absolutely seems like they're on the path to creating that instructionless controller that's capable of meeting pretty demanding standards of today's advanced aquarium controllers. Straight to the point, the biggest component of all this is the most popular aquarium controller in the US right now has a few limited pre-configured outlet options. For the most part, you'll have to be willing to write code or search for code examples on the internet to get it to do what you want on anything but the most basic tank. For those of us that have already learned the code and how to implement it, it's kind of fun, like a cool puzzle, and there's absolutely some pride involved in implementing it correctly. However, for a vast majority of us, if we're being honest with ourselves, there isn't a single other product in our lives where we would accept writing lines of code as a way to operate our device. Not a phone, laptop, TV, tablet, literally not a single thing in our lives which has been purchased in the last 20 years behaves that way, and to be frank, most of us would probably laugh if we were asked to accept that. Now, if that's the only option, it absolutely can be the best option on the market, and in this case it certainly is, but only until a competitor changes that game, and from what I've I've seen, I think the Cerebra might be the beginning of that path. So let's take a little deeper look into the Cerebra and you can decide for yourself. I'm going to dive right into the programming because that's what we've been talking about today. After that, we'll cover some of the hardware elements. Keep in mind that this is a beta version and any of this could change, but probably only for the better. I also haven't had a chance to run it on a tank or see the cloud connectivity yet, but I look forward to both. I'm going to start off by programming an outlet, and while I wouldn't call this process instructionless, when you do take 2 minutes to understand one, you'll almost certainly get the fundamentals, which allows you to do almost all the rest almost instantly. We're not going to have to write a single line of code, and I'm going to select some equipment that requires at least 3 inputs or sensors to control, which would either be completely impossible to do or next to impossible to do for most of the controllers out there without a significant amount of research. Let's start off with an alkalinity dosing pump where I want it to be on for 25 minutes 3 times a day, turn off the dosing pump if the pH ever gets over 8.5, and turn off based on a float switch if the water level ever gets too high. One of the cool things about the Cerebra is it runs off Android and it's open source, and they've really owned the fact that many reefers want an easy way to access the tank's functions right at the tank, but also an attractive display which shows the outlet states and all kinds of tank parameters, all of which is totally customizable. The Android platform also works with many of the off-the-shelf components like a USB mouse or keyboard. The USB ports in the Cerebra are real USB ports rather than power supply cables. I will say right off the bat that the screen is resistive, meaning it requires a tiny bit of pressure to work, meaning a more deliberate press and move rather than a swipe, which makes it a bit less responsive than a capacitive screen on our phones that we're all used to. At first glance, this might seem kind of disappointing, but the difference here is the resistive screens work with wet fingers. Initially, I said I don't care and I'd rather have a more responsive type of screen, but after messing with the Cerebra, I realized how often my fingers really are wet when I'm messing with the tank and controller, so there is a trade-off here. This is also why adding an off-the-shelf tablet to a controller might not be the exact same experience. Wet fingers typically won't work. It'll be interesting to see what other users think. That said, for the initial setup where you're doing a lot more work, I'd personally use a wireless mouse or keyboard with a trackpad, and what we're going to show here. First step is to open up one of the outlets you're connecting your dosing pump to and name it Elk Dose. Then under State, you can set the outlet to always on, always off, or auto, which will run off your sensor and other settings, which we want, so select auto. There are also some display, power settings, and feed modes which don't really apply to this outlet, so we'll skip those. In the fail-safe state, this is the state we want the outlet to default to if the head were to ever get disconnected from the power bar. In this case, we want it to be off. The upper and lower alert level are power monitoring settings to send alarms at any time there's an outlet, which is supposed to be on, but it's consuming more than 7.5 amps or 0 milliamps. In both cases, this would be an issue. This will tell us if our dosing pump has somehow failed and no longer turning on. You can, of course, change either one of these values to higher or lower amps or milliamps to best fit the type of equipment you're controlling. This type of power monitoring and alarms for failed or failing equipment, I think, is the biggest game changer for the newest generation of controllers. This would seem like a transition to us from a world where we not only instantly know of equipment failure, but we can also use information like this to intelligently identify equipment which is struggling before it actually fails. The last piece is where everything changes for the controller world. Rather than writing code to control this outlet, we're just going to create a few rules for it to follow that almost anyone can understand. So select Create a New Rule. You'll see all kinds of sensors and switches available to you. We're going to start by selecting the clock, name it Elk Timer, skip some of the advanced settings you can play with later if you like, and open Time Schedule. Click the plus button 3 times to create the 3 times we want our doser to be turned on and adjust the times. In this case, I'll select 1 to 125, 3 to 325, and 5 to 525. Then hit save and back out. The doser is now programmed to turn on 3 times a day for 25 minutes each and at the exact times you want it. So we also want to add pH control. It's almost the exact same. Create a new rule, select the pH probe as a sensor for the rule, name it Elk pH and save, then your target value, which in this case might be 8.5. Rather than use hard to understand words like hysteresis, there's a tolerance range which we'll set to 0.2, meaning we'll allow the pH to drop 0.2 points or back down to 8.3 before turning the doser back on, so the outlet doesn't switch on and off constantly right at 8.5. You might want to set it higher in some cases. We can also use our level sensors to turn off the doser if the water level ever rises. Same thing, create a rule, select level sensor, and name it alkalinity float. Note at this point you can see all your other rules for this outlet up top as well, but that's all there is to this one. Now when your float is triggered, it will also turn off your doser. Note there are some advanced settings down there for the switch on delay, being that the float will have to have been triggered for a period of time to activate the outlet so things don't turn on and off with small fluctuations in water level. And there's also a maximum time on based on the float switch. They're both much more likely to be used in an auto top-off solution, so we'll leave them alone. So that's all there is to it, just some easy to use drop downs which are pretty darn intuitive, capable of doing almost everything you could ever want to. And I think the average reefer who's familiar with controllers could figure it out on their own without a single sheet of instructions. For those of you that are really new to controllers, they could probably watch a 10-minute video and start to get the hang of it almost immediately. I'm not going to bore you to death with programming every last outlet because they're all almost exactly the same. Title your outlet and add a few rules to control it. You can use dissolved oxygen, multiple pH sensors, ORP, PAR sensors, salinity, multiple level sensors, clocks, all kinds of stuff. Because it's Android, setting things up like Wi-Fi is ridiculously easy as well. Open up your system settings, hit your Wi-Fi, locate your router, and enter your password, just like you would on your phone or any other device. Things like calibrating your probes are also super easy. Click on the pH probe, enter the calibration solutions you typically use, click calibrate, and just follow a few steps. It intelligently knows when to change the solutions and will even tell you the quality or condition of the probe that you're using at the end, I presume based on how quickly it was able to find the stable reading. Same thing for your temp probe. Click on the temp probe icon, calibrate, and enter your calibration temp based off your thermometers, and you're done. No mucking about in other interfaces or complex systems, just super simple, and again, anyone could figure this out without a single set of instructions. Notice there are also 0 to 10 volt inputs to control lights and power heads. Click on the icon, device type pump, then wave type, and select from all kinds of waveforms for your power heads, which you can use on any 0 to 10 volt pump. Then under wave shaping, select the max and min speeds for your pump. Just simple and easy. One more thing I think anyone can do without a single set of instructions and right at the tank. Lighting programs are similar, but you can just add intensity points based on the time of day. And if you don't want to use programs like this, you can just use the generic 0 to 10 volt programming. Last bit of this is I've been told that they're working on taking all of this one step further, and rather than having just rules for the outlets, they're likely going to have outlet wizards designed around actual equipment rather than outlets, which is a huge step forward. End of the day, none of us are programming an outlet. We're programming a skimmer, doser, return pump, UV sterilizer, or ozone generator, and the Cerebra is going to give you preset options for all of those so you can set it up not just intelligently but also in seconds without a single set of instructions. Even the newest reefer can have the most advanced setup and protections out there. I haven't seen the final release yet, but I have to say it absolutely seems like they're on the right track from a user experience and software perspective, and this opens the door to basically anyone who wants to use a controller because the knowledge barrier is almost erased. You'll probably have to learn a few quick elements, but the days of reading hundreds of pages of a manual and writing advanced code are pretty much over, and to be frank, because of that, I would fully expect to see competitors step up their game and follow suit. This is going to be a whole new world for everyone that most benefits you guys, the reefers. From a hardware perspective, it's also pretty impressive. There's obviously a full color touchscreen display, and the system is housed in a solid aluminum housing where form matches function. Same thing with the full relayed power bars, solid aluminum bodies. There are two types of power bars, one which just has controllable outlets and one with sensors. The sensor version has more sensor ports than any other controller popular in the US, with 2 pH ports, an ORP port, dissolved oxygen port, conductivity or salinity port, 2 0 to 10 volts, 3 switch ports which plug directly into the Vertex float switches and don't need a breakout box, including a dual level float sensor, and temp probes plug directly into the USB port on the Cerebra. Note these are not your ordinary temp probes, and they're obviously more advanced than your standard probe, and because they have a USB connection, they can even do things like provide visual feedback if the temp is in the correct range. In general, it's pretty easy to look at any element of the hardware and instantly tell the hardware is pretty superior to the rest of the stuff that's out there in the aquarium controller market. I don't know the exact details on pricing and what's included in the various packages yet, but I have been told that I shouldn't expect it to be more than what's already out there. I guess I can't wait to see all the release details. I kind of expect some type of soft launch with a product as advanced as this, but we'll wait and see. So last week we asked all of you if a PAR meter is worth the investment, and a pretty astounding 59% of you thought it was. If you include the only for advanced tanks, we're over 80%. This week we're asking all of you, how big of a deal is writing code for your controller? All of us here at BRS, and I know the community is super interested to know what you think, so hit that I in the upper right hand corner. If you learned something new today, let us know with a quick thumbs up, and don't forget to subscribe because you don't want to miss out on week 48 dealing with algae.